And welcome back, one and all, to Chapter 5, Lesson 6. We'll call this Lesson 6, Part B, Least Common Multiples. First, pause, take a look at the answers from the previous assignment, page 133, 13 to 22, 31 to 38. Come on back when you're ready. So, folks, we're going to build off of what we did yesterday. What we did yesterday was greatest common factor of expressions, numbers as well as expressions. And now we go into least common multiple. So by the end of today, we should be able to look at two algebraic expressions, not only come up with the greatest common factor, but also the least common multiple. All this to help us either reduce, simplify, or to compute, add, subtract, algebraic fractions. That'll come up in Algebra 1. Go ahead and pause, page 133, 49 to 58, 62 to 70. Come on back when you are ready. All right. Once upon a time, back in the days of old, if you were asked to find the least common multiple of 6 and 9, you would have to sit there and list out all the multiples of 6 and all the multiples of 9 until you found one or more common multiples. In this case, the least common multiple would be 54. Now, of course, if numbers go on forever, eventually you'll come up with others, right? I mean, it's going to happen, and others, and others, and still others. Now, that's a fine method for numbers that are small or for numbers that have a small least common multiple. But what if instead of 6 and 9, you were looking for 76 and 399? Yeah, not so great of a method. And so we're going to learn a new method today using prime factorization. So first things first, I'm going to split up 18 into its prime factors. You already know this from previous lessons. So the factors, the prime factorization of 18 is 2 times 3 times 3. Now let's do the same thing with 24. And don't forget, if you're struggling, at least for a while, go ahead and write the first few prime numbers down and just kind of go in order. Notice that 2 goes into both 24 and 12. 2 goes into 6. 2 does not go into 3, but 3 goes into 3. And so the prime factorization of 24 will be 2 times 2 times 2 times 3. Now, different rules for least common multiple than for greatest common factor. But we start with the same idea. Circle everything that's in common and write it once. In other words, you almost look for the GCF first. But then you're going to take each and every factor that is not listed and you're going to multiply by those as well. So in this case, we have another factor of 3. I'm going to multiply by 3. We have another factor of 2 that's not shared, so I'm going to put the 2 there. And we have another factor of 2 that's not there. So those 3 are not shared, but will be needed to find the least common multiple. Now check this out. Go through this bit by bit. 2 times 3 is 6. 6 times 3 is 18. 18 times 2 is 36, and 36 times 2, ladies and gents, is 72. The least common multiple of 18 and 24 is 72. Should you ever want to check it, you can make sure, okay, 24 times 3 is 72, and 18 times 4 is 72. There is no number less than that. Please notice that once again, anything you have circled, let me use a different color. If it's in common, you only write it once. If it is shared, you only write it once. If it is not, you write each additional factor once. I'll say that again. If it's shared, you only write it once. And then you multiply by each additional factor. Keep that in mind as we go on to other examples. Pause, rewind if you need to. Let's try 6 and 10 and 15. Now, many of you can do this without upside down division, but for those of you that need to see it, 6 is equal to 2 times 3. 10 is equal to 2 times 5. And 15 is equal to 3 times 5. Now this, ladies and gents, is going to be a slightly different beast because We're not looking for the greatest common factor. We're looking for the least common multiple. So when I say write each shared factor only once, it's okay if they're only shared by 2 of them. Let me say that again. When you're writing down shared factors, it's okay if it's only shared by 2 of these original numbers. Oh, and speaking of, I almost missed the 3, didn't I? So don't write 3 twice, write 3 once. In this case, 2 times 5 is 10, 10 times 3 is 30, and some of you might have already recognized that 6 times 5 is 30, 10 times 3 is 30, and 15 times 2 is 30. 30 is the greatest common factor. Now least common multiple. Now let's say I did not notice that the 3 was shared, and I wrote times 3, I'll use a little disappearing ink here, times another 3. Well, 2 times 5 is 10, times 3 is 30, times 3 is 90. And 90, while it is a common multiple, it is not the least common multiple. So it is important, ladies and gents, if it's shared by at least 2 of the numbers, to write it once and only once. Do not write it multiple times. All right, so we've done 2 examples that are numeric. The first example had 2 numbers, 18 and 24. The second example had 3 numbers, but you see the similarities, you see the differences. Write the prime factorization. Circle anything that's in common, and write anything that's in common once and only once. Then, if there's any other factor that is not shared, write each of those factors. All right, now let's go ahead and use this for algebraic functions, for algebraic expressions. So naturally 10 can break down, 15 can break down. We just did both of those. But notice that 10r to the third s. Not only do we need to break down the number, the coefficient, but we also need to write an expanded form of each and every variable. Noticing that there's a single s here, not that you have to write the one, but it might help some folks. Let's go ahead with the next quantity. 15, the coefficient, can break into its prime factors of 3 and 5. And then we have times r times r times s times s. All right. First and foremost, they both share a 5. They also both share an r. Oh, and they share another r. They also both share an s. But now let's look at what is not shared. There is a 2. Should I put it in front or behind? It doesn't matter what order you put it. I'm kind of tempted to put it in front. So, but we write the 2 only once, and there is also a 3. We're going to write the 3 only once. We're going to write another r, and we're going to write another s. So please notice anything that is circled, anything that's in common, you only write once. It's almost like you're looking for the greatest common factor. In fact, in this case, that is the greatest common factor. But then you're also looking for anything that is not shared and writing those ones. So let's go ahead and just multiply that out for the final answer. 3 times 2 is 6, 6 times 5 is 30. R times another r will be r to the third power. You multiply a bunch of r's repeatedly, and s times another s will be multiplying s squared. And so our least common multiple is 30 times r to the third power times s to the second. Now, while this is very different than the previous example because it has variables, it is similar in that you write out the prime factorization, you circle everything that's in common, and you write anything that's in common once and only once. Then you identify any other factor, and you write each of those. Finally, multiply out, and there's your least common multiple. Let's do one more of those, folks. Let's crank it up a notch. With 25ab, 25, the coefficient can be expanded out to 5 times an a times a b. 15 a to the second power, b to the second power. The coefficient 15 can be expanded out. And then we have a times itself repeatedly and b times itself repeatedly. All right, let's go through this piece by piece. What is shared? Write it once and only once. There's another a that's shared. And there is a b that's shared. I'm going to keep circling these just to help you with the visual. But not only do they have some numbers shared in common, in fact, that's the greatest common factor right there, but we also have a 3 and a 5. So we're going to multiply by each of those. We also have an additional a and an additional b. Those are all the factors that are not shared. If we were to multiply these, 5 times 5 is 25 times 3 is 75. A times a is a to the second power. B times b is b to the second power. No more simplifying can be done. And so the least common multiple of these two quantities is 75, a to the second, b to the second. Now, if you don't believe it, 25 times 3, a times another a, b times another b, will give us 75a squared b squared. Meanwhile, 15 times 5, and we don't even need any more a's and b's, will give us the same quantity. So, to find the least common multiple, expand everything out to its prime factorization. That's the first step. Following that, circle what's in common, almost like you're finding the greatest common factor, and write those shared factors once and only once. Notice the 5 got written once, as well as the shared A and the shared B. Again, this is very similar, if not identical, to finding the greatest common factor. The key now is, the new part is, take each factor that is not shared in common and multiply by those factors. It's almost like taking the leftovers and putting them in. All right, folks, that's all I have for today. Page 133, 49 to 58, 62 to 70. Take your time, do well, and let's grow.